Hello, everyone. My name is Lumir Filipov, and I have the honor to moderate this webinar. So, as all of you know, the name of the webinar is From Waste to Value. So maybe this is the most important question, actually, how we can turn the waste into value and added value for all the companies. Now we are going to speak about how we could transfer the wastewater treatment sector and can make that sector contribute towards mitigating the energy crisis in the Danube region. All companies, no matter whether they're water companies or just production companies, are facing the problems with the increasing cost of energy. Now in our session, we will have representatives from the international financial institutions and also from the real business, which could share with us their experience in how they could reduce their energy costs due to different energy efficiency measures and production of green energy. Actually, the production of a green energy in the wastewater treatment plants is something that each water company should target towards. Me being a representative of Sofia Water Company, actually we are have a very stable production of green energy. And that's what I could share with the audience. For example, in 2021, we produced around 24 gigawatts of electricity, which actually covered 115% of the consumption of the plant. That makes our plant one of the second most efficient, energy efficient plant in the whole Veolia group, since Sofia Water Company is part of Veolia. So the importance of the production of the green energy towards reduction of the cost of the energy is something very important. It has its business rationale. But before going towards the main presentations and before presenting to the panelists, I'll give the word to Katerina Schilling, which will say a few words about the housekeeping and the technical stuff around that session. Kati.
Yeah, thank you, Lubomir, and good afternoon also from my side. My name is Katerina Schilling, and I'm with IWD, and will go and share with you some of the basic housekeeping. Just for your info, this session will be recorded and made available online. And following the DWP KnowNow webinar, an on-demand recording and the session summary, as well as the presentation, will be shared and published on our Voice of the Danube website. And all of you that have registered for this event will also receive an email to inform you that everything is online available. In addition, please note that we have two opportunities for you to interact. One would be the chat box. This is more for general functions. So, for example, if you would like to, you could introduce yourself in the chat. In addition, we have the Q&A function. This is explicitly for questions to our panelists. The panelists can respond to your question directly in this Q&A box in written form, or we will also pick questions also to respond orally to you. We do not have the raise hand option, so just please note that. That's it already from my side, and back to you, Lubomir.
Thank you, Kati. Actually, you can see on the slide our three panelists. Actually, first we will start from, let's say, business point of view, and we will present you some practices from different companies to demonstrate and showcase how they are managing their energy efficiency and what kind of measures they are taking, I mean, from a technical point of view, towards reduction of their energy costs and probably production of green energy. So, ladies first, let's start with Frosela Filo from Albania and Korču Water Company. So, Frosela, please tell a few words about you and your company, and we are ready to listen to your presentation and your feedback on the topic.
Hello, everyone. I am Frosela Filho. I am the commercial director in Coastal Water Supply and Sanitation Utility that operate in Albania. My background is the financial and organization management, and today I want to share with you our experiences in producing renewable energy for the through the photovoltaic solar panels and for the demand of the wastewater treatment plant electricity. Okay, I think that water utilities that are early adopters of new technologies producing renewable energy have the opportunity to be the head of the curve and contribute to accelerate the wider uptake of clean technologies in the water sector and provide knowledge and expertise to the other small and medium utilities that want to improve their performance, especially in the electricity demand. So the big question nowadays for all the utilities is how we continue to manage increasing energy price on the PQ market. And this problem we should cope in a way that allow us to deliver our high quality services and maintain also at the same time aging infrastructure. If I say something about Albania, the situation in our country is that electricity price increased from January 2022 with 60 to 7% just for medium power voltage, including here also the water utilities, which are a bigger consumer of medium voltage electricity. This situation has begun to indicate in the water utilities and has impact in a dual way. The first is the direct impact of increasing cost and cost of energy of producing drinking water and also wastewater treatment. So immediately we increase the operational and maintenance costs. And the second impact is the indirect impact because we have an increase of overall prices in Albania as a result of electricity increase and all the purchased product and service that utility made are increased. So we have increased the overall cost for our utilities. In these conditions, we have for higher cost, we have a lower profit and maybe we have a financial losses and in the short time we reduce liquidity for our payment, and also in the long-term impact, we maybe the situation impact on financial capacity to enable capital investments. This is the darkest part that we are going through, but now I'm glad to determine that these difficulties they have changed our behavior by making us thinking that utility have so many opportunities to be the energy generator. Renewable energy in Albania has slowly crept into the water and wastewater industry as the economic benefits, but there is still potential for significant improvement. My company, Coastal Water Supply and Sanitation, is the first Albanian utility that produce renewable energy through photovoltaic panels for wastewater treatment plant energy demand. The situation of energy cost in my utility has had significant fluctuation closely related to the investments that are made and technology used for the production, drinking water, and also wastewater treatment. Before the photovoltaic power plant was built, the cost of energy was 12 to 50% of operating cost because we produce water through pumping station and also treat wastewater through aerobic digestion, and both of systems need huge of electricity. So the challenge of my utility after implementation the capital investment, is how to find a solution to produce electricity for our demand. Wastewater treatment plant that operated in our company operated with aerated diagrams, which it wasn't suitable to produce electricity because the process is aerobic. So in occurring in a situation, we find another solution, building the photovoltaic power plants for our electricity demand. The photovoltaic was built near the wastewater treatment plant and has a very good performance because it helped by the climatic conditions which are very suitable in our city, because Korça city is the city that have an average of 300 days of sunshine, and also the solar radiation is in a very good level, let's say. The capacity of photovoltaic power plant is 1.3 million kilowatt hour per year, as much as the average of the wastewater treatment plant consumed electricity. In these 7 years of operating, the photovoltaic power plant covers about 97% of energy consumption by the wastewater treatment plant. So we have reduced the energy cost from 12 to 6% of operation cost. But we are still halfway, because we produce renewable energy just only for wastewater treatment plant, not for the pumping station that produce drinking water for the city of Korça. So actually, combined with the fluctuation of electricity price, actually we have an energy cost in 12 to 50% of operating cost. So we want to extend right now our photovoltaic solar panels for the drinking water electricity demand. This extent photovoltaic will be in a capacity of 2 million kilowatt hour per year. I want to emphasize that this ambitious project is not easy, because especially in developing countries that often lack the capacity of financing subsidized or grants. So maybe we want to obtain low rate loans or maybe a grant for national or international financial institutions to produce renewable energy, and also to create a sustainability financial position in the future. So if we realize this ambitious project, maybe in the future, we will be the first Albanian utility that producing 100% renewable energy for our demand, and in the same time reducing carbon emissions and increasing energy independence, which is very important nowadays, affordability, and also a strong financial capacity. This is my presentation for my company that I prepared for you today.
Thank you, Forsela. Definitely looking for different options to diversify, let's say, the way of production of electricity is the right approach. Yes, the photovoltaic panels are one of the solutions into this. Actually, in Sofia water plants, now we are looking for such similar projects as well. Forsela, do you, for example, have another, let's say, ideas for another type of energy efficiency measures which you are going to implement in order to reduce the energy costs, or so far your analysis is showing that the photovoltaic panels are the most efficient way for this?
I think the best solution is to extend our photovoltaic solar panels, because as I say, we produce in a high level capacity electricity, and for the moment, this is the best way to mitigate, to solve this situation.
Okay, I understand. I see. So now maybe from Albania to move to Austria and to see what kind of solutions they have over there. So Gerald will say a few words about how they are dealing with that problem, because this is a problem. And let's see what kind of solutions they have over there. Gerald, the floor is yours.
Yeah, hello everybody. My name is Gerald Wandl and I'm working with EBS Wien, which is the wastewater treatment company of the city of Vienna. Vienna has one big treatment plant, the formerly main wastewater treatment plant with a dimension of 4 million population equivalents. And we are dealing with energy topics already since approximately 15 years. First of all, with some smaller project, but since 2010 with a really big project that is now finished already, and I can tell you some experience on that. We are designed for 4 million population equivalents, and we need to treat 3.2 million population equivalents as yearly mean value. And for this treatment, we need approximately 60,000 megawatt hours per year. And of course, this is a big issue because it's nearly roughly 1% of the city's electricity demand. And therefore, we searched for some solutions to reduce, of course, energy consumption on the one hand and to produce some green energy on the other hand. We are operating, for example, 2 hydroelectric turbines in the effluent channel of the plant, where we have different level differences that we can make use of. We have a Kaplan turbine, which is able to produce up to 1.3 million kilowatt hours per year from the effluent level difference to the Danube River. And we have a wastewater hydroelectric screw, which makes use of a level difference of 1.9 meters only. There you can't operate the Kaplan turbine very good, but this screw works quite well, and it produces around 500,000 kilowatt hours per year. So these two measures make around 2% of our electricity consumption, of a yearly electricity consumption, and therefore we searched for some other possibilities. In Vienna, the treatment plant works already since 1980, and from that time on, we had for sludge treatment a raw sludge incineration, which means we put out the primary and the excess sludge of the treatment plant, put it directly to dewatering and incineration to the incineration plant. They made use of the energy of the sludge by producing heat energy for the district heating grid already in former days from 1980. But in the early 2000s, of course, we got new possibilities, technological possibilities, good and economically working gas engines that we can make use of it, and therefore we calculated our sludge system new. We made an economical calculation what would mean if we change our sludge treatment system to anaerobic digestion and make use of the energy of the digester's gas. And of course, this has a lot of consequences in a big treatment plant like in Vienna. We had, of course, space problems because we needed to build some anaerobic digesters that we didn't have up to this moment. And of course, it has also big consequences on the incineration plant, because the sludge from digesters has less energy content than the sludge, the raw sludge from primary and excess sludge distribution. And therefore we made different economical feasibility studies, and this economical feasibility study turned out to be positive for the anaerobic digestion project. What means this in numbers? Maybe I can give you some numbers. Maybe I have also to mention that this digester project was only therefore possible because we had to renew our first biological treatment step, and with this renewal, it was possible to create some space to build also the digester. That was the basics for being able to implement our new process. Yes, we had some innovative aspects in the project that makes the project really economically feasible. We tried to reduce the aeration energy as much as possible. We have a very favorable treatment process in Vienna because we have a two-stage biological treatment together with primary sedimentation, which means that we produce a lot of sludge in comparison to a single-stage treatment process. And therefore, we can also produce a lot of gas in comparison to a single-stage process. But reducing the aeration energy is, of course, the most valuable thing, because aeration needs 2/3 of the total electrical energy demand. And therefore, we reduced the sludge retention time of our first biological stage to a minimum, where microorganisms need less energy for aeration and respiration. And so we could reduce the aeration energy. And we also implemented in the project the biological sludge liquor treatment stage with energy efficient nitritation stage. So we nitritate the centrate water only to nitrite nitrogen, but not to nitrate nitrogen, which also saves some energy. And the third thing was that we made pilot plant investigations because we wanted to feed our digesters with relatively high dry solids concentrations of 8%, and therefore save some, of course, digester volume that has to be built, but on the other hand, also some heat energy to heat the sludge, the raw sludge, before it enters the digester. So these three components are a big issue to get an energy efficient and also economically efficient turnaround in the sludge treatment from raw sludge incineration to anaerobic digested sludge treatment. So what is the result out of this? We have now an energy demand of 64 million kilowatt hours per year, and we can produce around 78 million kilowatt hours per year with our new gas engines electricity. So as yearly mean value, we feed around, let's say, 15 gigawatt hours electricity to the electrical grid of Vienna. But of course, we also need it during high peak loads, some electricity from the grid still, because we have peak loads during rain events, for example, and then we are not able to cover the total energy demand of the plant only with the digester gas. And what is also very, very important to get economically feasible is to use the heat power of the combined heat and power station quite to 100%. So we produce around 82 million kilowatt hours of heat energy with our CHP plant, and we need around 40 million kilowatt hours. So we are able to give around half of the heat power to the district heating system of the plant. And with this measure, in total, of course, we reduced the energy demand of the plant dramatically, and also the costs for the energy dramatically. Yes, and of course, is of course a big investment of in our case around 200 million euros, but I think we will have in 15 years we will have a positive effect on this measure, or that we expect for the next years. Well, additionally, I can mention that we have some spaces made available for the energy company of the city of Vienna named Wien Energie, and they built also a photovoltaic power plant at our treatment plant area, which also covers some I don't know, I think so nearly 1 million kilowatt hours per year of energy, which is fed directly to the electrical grid. And at the moment, this energy company, Wien Energie, builds also a heat power plant, which makes use of the effluent heat energy. And it's planned that around 40 megawatt of heat power can taken out of the effluent and fed into the district heating grid. In the future, it will be finished in, I think, next year in spring, and then we will the first step, and then we will see how big it can go. But they plan to heat around 100,000 households with this heat energy from the plant effluent of Vienna. So these is a little overview of our energy-related topics at the treatment plant, and would be glad to answer some questions on that.
Thank you, Gerald, for the interesting overview of the situation in Vienna. Obviously, you have a different ways for, let's say, making a green energy. So I'm wondering, did you have some kind of, let's say, targets? What kind of, let's say, types of production of green energy you have to use, or this is entirely on your decision as a plant manager?
It was interesting that when we carried out our project and we decided to build the CHP engines, it was some question coming from the city if it was possible to make green gas out of our biogas, but it was really too late because the project was too far grown at that moment. Yes, but I know that a lot of countries in Europe are dealing with green gas issues, and they want to make use, of course, also this gas. And yes, and there are some new developments, of course, to make use of the CO2 with the H2 produced from green electricity. So maybe we go further on in this way in the future, but it's not clear at the moment.
Okay, thank you for the interesting presentation. So we had so far two different examples from Albania and from Austria. Now it's good to see a little bit, let's say, a bigger frame, like a policy making frame. So the overview and let's say the experience of the World Bank on this will be very interesting. So we have Christopher here, and the floor is yours. Please give us, let's say, your experience on energy efficiency measures and how the IFIs and especially the World Bank could contribute for, let's say, mitigating the cost of the electricity and making more green electricity.
Thank you so much. Yes, I am Chris Welsine. I'm a senior water and sanitation specialist with the World Bank. I'm normally in Washington, but right now I am in Bangalore, India, and that's why I'm sitting in my hotel room. So please bear with me, but I hope you can see the presentation. I'll be giving you sort of a high-level view of waste to water, or how we or the World Bank view this waste to water. And then I have an offer to you towards the end of the presentation, just to keep you keep you watching. So I think when it comes to sludge, there's one overall question we can make. Sludge, is it a pollutant or a potential resource? And I think putting it very simply like this, because many utilities, it's kind of an expense. It's a pollutant that has to be removed, and then for others, and some of the very advanced wastewater utilities, it's become a resource. And actually, recently I talked to DC Water in Washington DC, and they say at a certain point we can give money for citizens to contribute to our sludge system, because that's how financially lucrative it could be down the line. So that's I guess the dream. So I think there's a need overall to move from a linear system where we are discharging the sludge and we are treating it to a certain point, and then it basically ends up as a cost to the wastewater utility, to a more circular system where it's fully renewable energy, and every process there's a cycle to it. And I think that's how we see some of the more advanced utilities in the world. They are moving to this. They are CO2 neutral. And I think that's where we see the industry heading. So I think the steps towards that, and I think you got a flair from two earlier speakers, is first of all to maximize the use of the existing infrastructure. To be energy efficient, and I can talk a little bit more about that, and to really embrace the use of renewable energy. I think the utilities that have biogas or methane capture, the utilities that are starting to look at solar panels for their land they may have, they are making a very good financial decision. But of course, as we know, many of the utilities are strapped for resources, so we can talk about financing options, etc. A little bit later. But I think it's important that wastewater utilities increasingly recover resources from water, from wastewater, and that we really embrace this overarching goal of carbon neutral wastewater utilities. And I think many of you listeners, this is a far-fetched dream that organizations like the World Bank keep telling you should really aim for this, but the road is long and it's really bumpy, and I think for many of you it's almost financially impossible. So let's try to be a little bit more specific. If we want to, of course, use biogas, create biosolids from wastewater treatment, then we have to embrace advanced water treatment. This is a picture from DC Water of their Gambi thermal hydrolysis system, one of the advantages, and I'm going to talk about that technology a little bit, just to give you a flair of one of these more recent, it's not really a new technology, but more recent technologies can do. Thermal dialysis, it really decreases the space used, and in urban centers where a lot of municipalities and where land is very expensive, reducing the space needed for wastewater treatment plant can really bring additional resources. You can put up solar panels, or you can sell off the land, if you will. This is what a thermal hydrolysis process looks like. It's fairly complex, but it really promotes the circular economy approach, which I talked about earlier, and it's free of pathogens, and it's probably one of the technologies that every wastewater utility should aim for. So this is also solutions that are used in DC and other countries around the world. So one of the benefits is methane capture, biogas, and the biogas, interestingly enough, can be used for the process. It can be used to generate electricity for the utility. It can be used to generate electricity for the national grid. And certain areas or certain cities have really embraced this biogas production and has linked it with transport, public bus systems that runs on biogas. And if anybody is able to close that loop, the financial benefits are enormous, because if you use biogas for public transportation, the return on investment is much larger than just generating electricity from it in most cities. So I think just mentioning that public sector, etc., is really, if I was a utility manager, I would say, well, that's a larger discussion that I'm not always able to have with the municipality, with the transport sector. So when we talk about waste to value, then it really means that many sectors are working together at the same time. The other advantages with these more advanced wastewater treatment solutions is that the sludge retention time is vastly reduced, and the volume that the system can digest is much higher than your sort of go-to or maybe status quo approach. The other advantage is that it has a reduction in odor, and then it, as I referred to before, it can produce these biosolids that can be like fertilizer for farmers. It can be sold for households. So in DC, in Washington DC, the wastewater utility has started to sell this product to farmers, to residents that wants fertilizer or biosolid, and it becomes a revenue generating activity to sell basically the waste material. And you can see here in terms of DC water biosolids budget, how it has dropped since they introduced it in 2014. And you can see the green, now they're actually starting to sell or commercialize the product. And I think that ties what I said before with, at a certain point, if utilities can commercialize this product, then the financial benefits are enormous. So just to talk about DC water again, so they reduced biosolids quantities by more than 50%, and if you're a wastewater utility manager, you know that what that can mean for your bottom line in terms of OPEX saved, etc. They've improved product quality, and they're generating 8 megawatts of clean renewable power, and they have cut CO2 emissions or greenhouse gas emissions dramatically, and they're saving millions of dollars. Of course, what's not on this slide is that they have also made a huge upfront investment. and they have talked, had a cross-sectional dialogue across water, agriculture, food waste, etc. So it's not as easy as this presentation might make it seem, but the benefits downstream are really, really large. In the UK, they're using the same process, but they have developed this in a very smart way. So normally on the left side, you have where you have smaller municipalities with a standalone sewage treatment plant. So what they've done in the UK, they have implemented these very more expensive solutions which can take a higher volume of sludge, and they are centralizing it, the sludge, to these centralized plants, and it basically looks like this. So from a sewage treatment plant is the black dots. It's liquid sludge. It goes into a decentralized dewatering center. It's dewatered, and the cake is transported into a central facility. And sometimes this transportation can be maybe 100 kilometers or even more. And Thames Water have done extensive financial analysis on this, and have found out that it's much more cost effective to take the liquid sludge, dewater it, and take it to a central high or advanced treatment facility and treat it there. So that's a very interesting approach. And I think, again, you will ask yourself the question, well, if I'm a small utility, or I'm a larger utility, but I need to do this with my surrounding municipalities, how does this work? Because then it again requires a larger dialogue. It requires a regional dialogue about how to treat sludge among regional municipalities. So it's difficult to do, but once implemented, as I said before, the financials are really stunning. So that's just a few examples from the UK and DC Water. And then I just want to take you to an example from Sofia wastewater treatment in Bulgaria. And here they're taking a more gradual approach. And I think maybe that's easier for utility managers to bite over. So you can see here over a 14-year period, they have made targeted, careful investments into making their system more energy efficient. And if you look, sorry about that. If you look at the trend of energy consumption, they are increasingly becoming self-sufficient. So you can see they're making these investments over the years, and they have a direct impact on the energy self-sufficiency, and also their ability to at some point go carbon neutral. So the World Bank has started to document, or has actually documented some of these lessons around the world, and we will share this presentation with you. There's much more information online on this, and there are several case studies. It's even annexed in this presentation, so you can take a much deeper look. IFC, our financial, the World Bank financial private sector lending arm, just recently came out with this very short report. I think it's six pages on how to scale rewater, and it basically touched upon the things that I just mentioned. Now, I know this is a tall order, and I just wanted to give you the high level view and also sort of the dream where some of these wastewaters in the future should be looking like. So there are really interesting and known challenges. Of course, policy challenges. There are feasibility challenges in terms of municipalities, utilities. How will they actually carry out these more in-depth feasibility studies to try to plan for the future? There are capacity constraints. I think that some utilities fear towards how do we long-term do we have the technical and financial capacity to sustain this in the long run? And of course, the overarching question, I think probably as much as the policy issue, financing is always a huge issue. But for most of you, you will in the future be measured on EU regulation. You will in the future be required to move towards carbon neutrality. Maybe you don't see it in your near future, but I think in the midterm horizon, you know that these requirements will come to you. So I think it's time for utilities to think about what policies need to be in place, what feasibility studies, what are the best practices, and I try to present some of them today to you. How do we deal with capacity and how do we finance this in the long term? And I think that's where the EU, the World Bank can come in and look at various financial models together with you. So I was asked to talk a little bit about energy efficiency, and I just touched on it a little bit. So it's important that that wastewater utilities conduct energy audits to understand, are we operating efficiently? Our pumps are working, but are they operating efficiently? We were talking to a private sector, an international private sector company. I'm sure you all know of it. And they have an approach to system optimization for wastewater utilities, where they, without any capex investment in you, if you will, just through system optimization, can really reach up to 30% energy savings just by optimizing the systems. So even if you don't have the financial resources, there are ways often where your systems can be optimized. Pump replacement, power corrections, etc., SCADA systems, continued monitoring and optimization. So of course there's not time for us to go into that, but I think it's important that wastewater utilities managers are curious and try to gain this information. Now, on the more medium-term horizon for the World Bank, I would propose the following. We need to identify and invest in these new technologies. And as I said before, it requires really a larger dialogue if we want to capture the economies of scale with these new technologies. It requires municipalities, wastewater utilities to work together. It requires a cross-sectoral dialogue about co-digestion. Will the policy allow agricultural waste, food waste to get higher volumes and produce more biogas? Is it possible for you to centralize with the approach I showed before with dewatering, etc., and try to think about what is the best from a financial return perspective in terms of biogas optimization? Is it to use it at utility? Is it to use it and sell it to the national grid? Is it to start a program around public transportation? So it requires a larger dialogue and an ability to look really at a holistic view when it comes to sludge or wastewater treatment. So my offer to you is that the World Bank is interested in this. We are interested in doing these kind of analysis where we, at a regional level or maybe even at a national level, look at creating a master plan for waste to value opportunities. So if you're interested, the World Bank has a little bit of funds to carry out these more holistical analysis to see if there is options for investing in the advanced wastewater treatment. So thank you very much. I just wanted to sort of get you a little bit curious and show you what the most advanced wastewater utilities are doing at the moment. If you're interested, reach out to Katie or reach out to me at this email address, and I'll be happy to take this forward. Thank you so much.
Thank you very much, Christopher, for the interesting presentation. Actually, we have seen different examples from different parts of the world, starting from Albania, going through Austria, then in the DC, and ending back in Sofia. Definitely, it really depends on the water utility, what kind of technology will be chosen, and what kind, let's say, what type of green energy will be produced. Now we are on the question and answer session. We have pretty interesting questions into the Q&A section. No matter, in my view, no matter what kind of technology will be chosen, at the end of the day, it's about regulatory incentives and way of financing. Because as Gerald said, all these measures are capital intensive. We need money for that. And the cash generation of each water operator, it's limited by the regulatory framework in place. So maybe it will be interesting for the audience to say a few words, the panelists to say a few words about the regulatory incentives and the financing. And actually, one of the questions for Sela is whether there are some kind of administrative or some other legal obstacles or technical ones related to the use of produced electricity, especially in Albania. And actually, what are the regulatory, let's say, incentives, and if there are such, in order you to invest into such, let's say, facilities? Okay, the cost will be lower. This is the economical rationale behind, but what else for Sela?
Well, in Albania, we have Energy Regulator Authority, which administrate all the producer of electricity. In our case, we produce renewable electricity, renewable energy, and we pay just an administrative fee. It's just a non-considerable fee. Because there are incentives that are being supported by the government, and we don't have any administrative fees to produce electricity. We just have the cost for operating that are at hours, but not to pay something to the authorities. It's just so, and the question, what is the question of the sludge, producing sludge? There are some costs. We have costs, staff costs, electricity costs, so that are considerable. We have also services cost, depreciation cost, interest for loan costs. There are several costs to treat sludge also. And as I say, our challenge is to find how to reduce cost and also how to increase producing energy for our demand, because electricity cost is very, very considerable in the wastewater treatment plant, and so in water utilities. We know is from 10%, maybe 30% or maybe 50% of the operational costs. And also is the question about what we do with sludge after treatment. In our case, wastewater treatment plant operated with aerated lagoons, and we treatment sludge with the aerobe systems. And after this sludge made strict regulation and quality standards according to the European Council directive, we use the sludge in the agriculture as a fertilizer. This is the cycle of our cleaning treatment of wastewater.
Thank you, Marcelo, for your answer of the questions. Maybe now it's good to come back to Vienna and Austria. There are a couple of questions for Gerald as well. Maybe one of the interesting questions, just to follow up what Marcelo said, what's going on with the sludge in Vienna, and actually what kind of sludge digestion is used in Vienna wastewater treatment plant. Because, for example, in Sofia, when we use the anaerobic digestion, after that we produce the methane gas, which we turn into electricity. And as I said, we use this for our internal demand, and the excess electricity is sold directly to the electricity exchange. Stock exchange. So what's the situation in Vienna? What's going on with the sludge first, and secondly, there is an interesting question whether you have over there a long-term power purchase agreement with other companies in Vienna. Gerald, the floor is yours.
Yes, thank you for the questions. Well, the situation in Vienna, I suppose it's nearly the same than in Sofia concerning the digestion process. We treat our primary and excess sludge in a static thickener and concentrate the sludge to 3.5% dry solids. Then we make a mechanical pre-thickening of the sludge with centrifuges up to a dry solids content of around 8%. And with this 8% dry solids content, we feed the digesters in Vienna. And we get out the biogas with around 60% of methane gas contribution. And this gas, with this gas, we operate the gas engines where we produce our electricity and the heat that we discharge to the district heating system and to the electrical power grid. That's for the question how it works with the digestion in Vienna. The sludge itself is then pumped to the incineration plant, which is located directly on the other side of the treatment plant. It's operated by the energy company of the city of Vienna, Wien Energie, and there it's dewatered before. Then a part of the sludge is also dried. With approximately 40% of the digested sludge are also dried, and a mixture of this dried sludge and the dewatered sludge is fed to the incinerators of the plant over there. And the residuals of this incineration process are at the moment deposited, and they are at the moment making some project concerning phosphorus recovery out of the ash of the incineration ash of the sludge. And yeah, dealing the second question, we have a long-term treaty with the electrical company, and we have the positive fact that we nearly get back the same money for discharged electricity than we have to pay for consumed electricity, which is also quite important issue for us, of course, because normally electrical companies don't pay much money in Austria for people that discharge their electricity to the grid. But in our case, it is good because it's a special issue in Vienna, maybe two public companies that are operating together.
Thank you, Gerald. Now talking about the technology of treatment and the residuals, I was thinking that actually that pops in my mind. A few years ago, we were discussing in Sophie Water Company the potential for production after we produce the green energy of production of RDF of the residues and given that to the cement factories. So this is something that we have analyzed in the past, but we didn't, let's say, go towards this because right now the sludge, the rest of the sludge, we are just giving to the farmers as a fertilizer. So at that moment, we could, let's say, give away the whole sludge to the farmers. But there is also a question here in that section about cooperation with the cement factories. Have you ever considered such partnership and such, let's say, production of RDF, or this is not the case for Vienna?
In Vienna, the special situation is that we sell our liquid sludge to the energy company to the incineration plant, and they have existing facilities which they operate. And I think they have now, of course, changing situation because formerly they got a raw sludge that they had to handle, and now they get the digested sludge. But in Austria, I think there is a lot of change also in sludge sludge treatment coming worse because Austrian wastewater treatment plants will have to be forced to get back some phosphorus out of the sludge, and therefore. It will be the case that the sludge of all bigger treatment plants will have to be incinerated in future.
Thank you. I see there's one other question for the produced heating from the CHP in Sofia and whether we distribute to the city. The answer of this so far not. During the winter we use the produced heat for internal heating of the plant, and during the summer, of course, we are not using this for heating and we are not distributing to the city. But the area where the treatment plant is located, it's a little bit far away from the city, and probably the connection to the grid and all that will not be very efficient. But yes, this is a topic and an option that should be additionally explored, especially in Sofia. Now I would like to go back to Christopher, and maybe if the World Bank has some, let's say, study or overview about the regulatory incentives on the investing in, let's say, facilities producing green energy or reducing the energy consumption. Have you ever made such a research? Are you aware of such a research? And what's the regulatory incentives on these different countries? Because as I said, if there are such regulatory incentives, definitely that will be something the water companies will be looking for. If there are not such regulatory incentives, yes, there still be interest, but maybe the interest will be a little bit lower on that.
Well, thank you so much. Yeah, I'm not familiar with a study we are currently doing or that we have done on regulatory incentive. I'll have to look for it. But of course, there's also the carbon market, which if this is done at scale, then that could provide an incentive. But of course, the carbon market is always a little bit difficult to harness, and there's a lot of upfront investment in that, so it may not always be lucrative or something that the wastewater utility would want to do. But okay, so the carbon market, but there are of course countries that have done this, and I think when the information I provided in the link, there's a lot of material there that from around the world, different settings that can case studies, etc. That speaks a little bit to that. but I'm not aware of a specific study on this. Perhaps Katie or Raymond could contribute. Over.
Thank you, Christopher. It will be maybe interesting for the region, and in Albania, for example, I'm going back to Frosela. I'll give a particular example from the Bulgarian model of regulation, because we are working under a 5 years regulatory framework. And when our business plans were approved, let's say 5 years ago, we put a certain amount of the electricity priced as a tariff element into the end tariff to the end customer. And obviously nowadays the prices of electricity they went up, and the allocation in the tariff is very small compared to the real price of the electricity. And now this is a very big problem for the water operators, because obviously they're not recovering the whole electricity cost through the tariff. And yes, producing green energy, selling green energy is mitigating that effect, but still you have that negative effect. And for example, now the government in Bulgaria is compensating the water operators for the difference between the tariff, electricity cost within the tariff, the existing tariff, and the real electricity cost. And now that difference is covered by the government for a particular time, part of time. So my question to Frosel and to Gerald, of course, is whether do you have such a situation, for example, in Albania, in Austria, or the tariff setting element and model it's working in a different way?
First, Albanian utility that produce renewable energy from the photovoltaic panels for our electricity demand. In Albania, we don't have, this process is very not developed so much in Albania. We don't have any regulatory frame to regulate this this trade, this market. Actually, we have increase of electricity in Albania from January 2022, and we are in the process. The government has a plan to support the water utilities for incentives that produce electricity. But Albania is, as I say, is in developing the trade electricity, and we are in the process. We are in the process right now, and as I say, our utility, Coastal Water Supply and Sanitation, we want financial support to implement the project for extending the photovoltaic panels electricity for the whole of electricity demand in our company. There is much more to do in this field in Albania, and especially in the water utilities, because the electricity is in a high range of maintenance and operation costs, maybe 50%. And actually, we need a huge support from others, from government, from financial institutions, because the price of electricity is increased very highly. For example, in Albania, the price of electricity is high with 70%, and this fact impact so much in our operational costs, so much more also in capacity for payment and to create the sustainability financial in the future. It's not easy for us.
Thank you, Frosela. Maybe a few words from Gerald as well for the situation in Vienna and
yes. Well, our electrical contract indicates also cost index, of course, where the cost for electricity are adapted to. But as I mentioned before, we get out nearly the same price for our electricity that we introduce to the net, and as we are a net provider of electricity, it's good for us if the electricity prices is high, because our return of investment will be getting better with that measure. I suppose a very special situation than in Vienna, because if you are not net provider of energy, electricity or heat, of course it's a big issue to be solved. And I think anyway, for example, in Austria, we have had in former days very good electricity prices, for instance, in comparison to German wastewater treatment operators that I know from discussions with them. But I don't know the reason why exactly.
Thank you, Gerald, for your answer. Actually, I'm seeing that we have covered most of the questions. Maybe another question to the panelists regarding to the sludge as a fertilizer. How are you dealing with the potential problems with the sludge as a fertilizer coming from the heavy metals, the potential content of heavy metals into the sludge? I guess you go through a very strict certification of the sludge, and just having that certificate, you can use that as a fertilizer, I guess. But is that the case?
Austria, especially, they made a new regulatory situation, and as I already mentioned, all bigger plants than 20,000 population equivalents must recover phosphorus in some specific way, and this leads to the fact that every treatment plant above 20,000 PE has to incinerate its sludge to meet this goal in the future. And of course, for fertilizer, sludge for fertilizer in agriculture, there are very strict constraints concerning the heavy metal content of the sludge.
Okay, thank you for the answer of this. I'm seeing that we are just running out of time. I believe that we have covered a pretty wide range of topics, like technical topics, commercial topics, regulatory topics. I hope that this webinar was useful for the participants, and that you didn't waste an hour and a half for that. Me personally, I learned new things, and it was very interesting to discuss on all these topics with our panelists and also our participants in the webinar. So thank you very much again for the participation into the webinar. I hope that we will see again on different topics as well. And I would like to wish you a nice afternoon.